Okay, so this is chapter 7 and this is talking about chemical formula and equations. So here we're going to learn how to write a chemical formula and how to write chemical equations. First of all, a chemical formula or a molecular formula is a formula showing the number of atoms in the molecule. So you can deduce that, for example, from the structure of the molecule. So if you have a structure like this and he says write the formula, all you're doing is you're counting the number of each of the atoms and putting it in the form of a molecular formula, something like this. So here you have 1 iron, 5 carbon atoms, 5 oxygen atoms. So this is how you write the formula of this compound. So this is another one. How do you write the formula of this? You count all the carbons, all the hydrogens, all the oxygens, and you compile them together. So this is C3H6O3. This is another one. Deduce the molecular formula of this compound. So this is just 1 S, 6 fluorines, and 1 oxygen. In this case, the order of the F and the O doesn't make a difference. When you have a compound like the one on top, if you have carbon and hydrogen, the carbon comes first and then the hydrogen and then the oxygen. If you have one like the previous one where we had a metal and then non-metals, usually the metal comes first. Okay, but then you can also write the molecular formula from the name of the compound. So if I tell you write the formula of a compound with a certain name, you write first the symbols and then you put the valency of one under the other. So the basic rule is write the symbols of each element, put the valency of one under the other. First of all, we need to know what is meant by valency. Some things you can deduce their valency from the periodic table. The word valency means the number of electrons that the atom needs to lose or gain in order to have a full outer shell. For example, we said anything in group 1 has 1 electron in its outermost shell. In order to have a full outer shell, it needs to lose that 1 extra electron, then it will have a full inner shell. The inner shell will be the outer shell, then it will have a full outer shell. So anyway, anything in group 1 needs to lose 1 electron in order to have a full outer shell, so we say its valency is 1. Anything in group 2 has 2 electrons in its outermost shell. It needs to lose them, so the valency is 2. Anything in group 3 needs to lose 3 electrons, valency 3. Anything in group 4 needs an extra 4 electrons, so this is valency 4. Now, anything in group 5 has 5 electrons in its outermost shell, and we said if it has 5 electrons in its outermost shell, it needs 3 more in order to have a full outer shell, so we say its valency is 3. Anything in group 6 has 6 electrons in its outermost shell. It needs 2 more electrons to have a full outer shell, so its valency is 2. Anything in group 7 needs 1 extra electron, so its valency is 1. So as we said, the valency is basically the number of electrons that the atom needs to gain or lose in order to have a full outer shell. So these are the things in the periodic table. So looking at anything in the periodic table, from the number of the group you can determine its valency. But then there are some things that are not in the periodic table. So these things you have to memorize. What is hydroxide, nitrate, nitrite, ammonium, carbonate, sulfate, phosphate? You need to memorize that. So if I say I want to write the formula of something hydroxide, you need to know that hydroxide is OH and its valency is 1. Nitrate is NO3, its valency is 1. Nitrite, NO2, its valency is 1. Remember that anything in the periodic table would be with a D. So for example, oxide is just oxygen from the periodic table. Nitride with a D is just the nitrogen in the periodic table. Sulfide with a D is the sulfur. Phosphide is the phosphorus. But anything 8 or 8, then it is one of these things that you need to memorize. So ammonium is NH4, valency 1. Carbonate is CO3, valency 2. Sulfate, SO4, valency 2. Phosphate, PO4, valency 3. You need to memorize all of this. So all of them have valency 1 except carbonate and sulfate have valency 2, and phosphate is the only one that we usually talk about that has a valency of 3. Okay, so we said to write a chemical formula, you write the symbols of each element and then put the valency of one under the other. So if you determine that the valency of something is 1 or 2 or 3, you put that number under the other element in the molecule. So let's try some of these. The formula of the main compound used as the source of sodium sulfate is sodium sulfate 10 water. How many different elements are shown in this formula? Elements means how many different symbols do you have. So you have Na, you should know that Na is a symbol for sodium, so that's one element. S is the symbol for sulfur. O is the symbol for oxygen. H is a symbol for hydrogen. So actually you have how many different elements? You have 4 different elements. Now what is the formula of the compound formed between magnesium and fluorine? You look at your periodic table. Where is magnesium and where is fluorine? Magnesium is in group 2. That means it has 2 electrons in its outermost shell, and that means that its valency is 2. Fluorine, you'll find it in group 7. Group 7 means it has 7 electrons in its outermost shell. It needs 1 more to have a full outer shell, so the valency of fluorine is 1. So I want to write magnesium fluoride. I have to write the symbol for magnesium, Mg, and the symbol for fluorine is F. And then I need to put the valency of one under the other. So we said magnesium has a valency of 2. I put the 2 under what? Under the F. Now the F has a valency of 1. We have a rule that 1 is understood. You never write 1 under the Mg. It is understood that it is 1. So your formula is which one? Your formula is the one that has MgF2. Do we understand how we got that? Okay. Give the formula of the 2 ions in LiF. Now again you're going to look at your periodic table. Where is Li? You'll find it in group 1. Where is fluorine? You'll find it in group 7. So Li is in group 1. That means it has a valency of 1. That means it needs to lose 1 electron. So when it forms an ion, it is Li+. The fluorine is in group 7. It needs 1 more electron. It gains 1 electron, and that means it becomes with a 1 negative charge. Okay? Now, he says the table shows formula of some positive and negative ions. Complete the table by giving the formula of the 3 missing compounds. So he wants you to write the formula of a compound made up of copper 2 plus and Cl minus. Remember that the number of the charges on the atom or on the ion is its valency. So when I say Cu2 plus, I'm talking about Cu that has a valency of 2. And Cl minus, 1 minus, that means it has a valency of 1. So I need to write the formula by writing the symbols of each one, and always the metal comes first. So it has to be Cu, Cl, not the other way around. And then the valency of one under the other. So we said the copper has a valency of 2. You put the 2 under the Cl. The Cl has a valency of 1. You don't write anything. You don't write 1 under the copper. So that is your formula of copper chloride, CuCl2. The other one is something between ammonium, which is NH4+, and sulfate, which is SO4 2-. Again, you need to write the formula of each one. And then you need to put the valency of one under the other. Now, what's the valency of ammonium? You should know, without even looking, you should know that ammonium has a valency of 1. When you look at it, he has 1 positive, that is a valency of 1. Now, sulfate has a valency of 2. It has 2 minuses on it. So you need to put the valency of one under the other. But in this case, the ammonium has a valency of 1, so I don't write anything under the sulfate. And remember that the SO4 is one entity that never changes. You cannot change anything in the SO4. Now, the NH4, I need to put under it 2 because the sulfate has a valency of 2. And we said we put the valency of 1 under the other. So the valency of sulfate goes under the ammonium. But the ammonium is a group of atoms. The ammonium is something made up of nitrogen and hydrogen. And I need to put the 2 to indicate that it is 2 of the ammonium, not 2 of only hydrogen or something. So I need to put the ammonium within brackets and then the 2 outside. Just like the previous one that he wrote for you, where he has Fe2SO4 bracket 3. Fe2 because the sulfate has a valency of 2, and SO4 bracket 3 because the Fe has a valency of 3. Okay, the last one that is empty in there is a compound between Fe3 plus and CO3 2 minus. So you want iron 3 with carbonate. Again, you're going to write the symbols of each one and then the valency of one under the other. So the Fe valency 3, you put the 3 under the other one, under the carbonate. The valency of carbonate is 2, you put the 2 under the Fe. Do we understand that? Okay, let's try this. The correct name of the compound with the formula CuSO4 is, first of all, is it sulfate or sulfite? We said, what is SO4? SO4 is sulfate. So your answer is either A or C. So it's either copper 1 or copper 2. So that means that the copper has either a valency of 1 or a valency of 2. Now you notice that there is no number below the Cu, there is no number below the SO4. That must mean that the copper has a valency of 2, the sulfate has a valency of 2, but when you have 2 here and 2 here, they cancel each other, and that is why you end up with nothing written under each of the components. No 2 under the copper, no 2 under the sulfate, because they canceled each other. So that means they cancel each other because the copper has a valency of 2. So your answer must be copper 2 sulfate. The next question says complete the table by giving the missing formula. So he wants the formula of lithium oxide. Again, to write the formula of lithium oxide, what do? We write the symbol of each one. Symbol of lithium is Li, and symbol of oxide, that's oxygen. So oxide, we said anything with a D is what you get out of the periodic table. In the periodic table it's written oxygen, but when it forms a compound it is something oxide, something nitride, phosphide, sulfide, and so on. So we said lithium is Li, oxygen is O. Now the valency of lithium is what? The valency of lithium is 1 because lithium is in group 1, so I don't write anything under the O. But the valency of oxygen is 2 because oxygen is in group 6. It has 6 electrons in its outer shell. That means it needs an extra 2 electrons to have a full outer shell, so its valency is 2. So I put the 2 under what? Under the lithium. Okay? How do we write the formula of the anion in lithium carbonate? If I have lithium carbonate, I have 2 lithium ions. Each lithium is from group 1. That means it has lost 1 electron, so it's Li+. What about the carbonate? The carbonate is CO3, and you know that the valency of carbonate is 2, so it is 2-. It is the anion. Anions are the ones with a minus charge, or a negative charge. Okay, there is another rule about writing the formula of acids. So to write the formula of an acid, you have to know anything acid has to start with H. So hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid all start with H's. And then you need to know what is after the H. If I'm talking about hydrochloric, that means after the H I have chlorine, which is Cl. And then I check the valencies. Please don't forget to check valencies. What is the valency of hydrogen? Hydrogen is something that has 1 electron. We said it needs only 1 more electron to have a full outer shell, and that means that its valency is 1. And when its valency is 1, that means I don't write anything under the Cl. Now the Cl is in group 7. We said that means it has 7 electrons in its outer shell. It needs 1 more electron, so its valency is 1. I don't write anything under the hydrogen. So that means that hydrochloric acid is HCl. Nitric acid. Acid starts with H. Now you are required to know that nitric acid is the acid that has nitrate. What is nitrate? Nitrate is NO3. Valency, go back and memorize these. Nitrate is NO3 with a valency of 1. So I don't write anything under the hydrogen and I don't write anything under the nitrate. Remember, nitrate always is NO3. It will never change. Now, sulfuric acid, acid starts with H. You are required to know that sulfuric is the acid that has sulfate. Sulfate is SO4, and SO4 has a valency of 2. Remember that we have only two things that have valency of 2, sulfate and carbonate. So sulfate has a valency of 2, so that means I have to put 2 under the hydrogen. The hydrogen has a valency of 1, so I don't write anything under the sulfate. Phosphoric acid. Acid starts with H. You are required to know that phosphoric acid is the acid that has phosphate. Phosphate is PO4, and PO4 is the only thing that we are required to memorize that has a valency of 3. So I put the 3 under the hydrogen. Carbonic acid, you should know that carbonic acid is the acid that has carbonate. So it's H with carbonate, and valency of carbonate is 2, so I put 2 under the hydrogen. Okay, there's another thing that you need to know, in that sometimes the name indicates the number of the atoms. Remember, we said the basic rule of writing the formula. You write the symbols and you put the valency of one under the other. But these are exceptions, because he is telling you what you should write. So for example, he says nitrogen monoxide, carbon monoxide, nitrogen dioxide, carbon dioxide, sulfur dioxide, sulfur trioxide. Anything mono means 1, di means 2, tri means 3. There is also tetra, that means 4. So if we say nitrogen monoxide, what you are required to write is, you are required to write nitrogen with only 1 oxygen next to it. And forget about valencies, because the valencies here do not apply. If you sit down and think about the valencies, this is not right. But this is what he's telling you to do. It should be carbon monoxide, nitrogen monoxide. So you write the symbol plus only 1 oxygen. Now, if I say something dioxide, means you write O2. Something trioxide means you write O3. So these are exceptions, and the rule of putting valency of one under the other does not apply. So let's try these together. How do we write the formula of sodium hydroxide? Again, you write the symbols of each one, Na and OH. And then you check valencies. Please do not forget to check valencies. The valency of sodium is 1 because it's something in group 1. The valency of hydroxide is 1, so I don't write anything under either of them. Potassium iodide. Potassium is K. Iodide is what you have in your periodic table as iodine. Remember, we said in the periodic table it's iodine. If I put it as a compound, it is something iodide. So potassium is K, iodine is I, valency of potassium is 1, valency of iodine is 1, and that's my formula. Lithium carbonate, you write the symbol of each one, the valency of one under the other. Remember that lithium is group 1, so that's valency 1, so you don't write anything extra under the CO3. But the valency of carbonate is 2, so you have to put 2 under the lithium. How do you write sulfuric acid? We said sulfuric acid is the acid that has what in it? Sulfate. And we said sulfate has a valency of 2. So acid, you start with H. Sulfuric has sulfate, and the valency of sulfate is 2. Copper 2 chloride. So you write the symbols of each one and the valency of one under the other. If I say copper 2, that means that the valency of copper is 2, and the valency of copper goes under the other one, not under itself. So you don't write Cu2. If I say copper 2 chloride, that means the valency of copper is 2, and we said we put the valency of 1 under the other. Aluminium sulfate. Again, you write the symbols and then you check the valencies. Aluminium is in group 3. It has a valency of 3. So you need to put 3 under the whole of sulfate. You don't change anything in the SO4. You put it in a bracket and you put the number outside the bracket. The valency of sulfate is 2, so I have to put 2 under aluminium. Iron 3 oxide. Iron is Fe, oxide is oxygen. The iron, if I say iron 3, that means that the valency of iron is 3, so I put the 3 under the what? Under the oxygen. And the oxygen has a valency of 2, so I put it under the iron. Now, calcium sulfate. Calcium is in group 2, so its valency is 2. But sulfate also has a valency of 2. So as we said, if this is 2 and this is 2, they cancel each other and you don't write 2 in either of them. So it's just a 1-to-1 ratio. Zinc phosphate, the symbols and then the valencies. The valency of zinc is always 2. And you need to remember that valency of zinc is always 2. No one is going to tell you the valency of zinc. So transition metals, usually they will tell you the valency, but the valency of zinc is always 2. It never changes. So valency of zinc is 2 and valency of phosphate is 3, and we put the 3 under the zinc. Are we feeling much better about that? Okay. Then we use this chemical formula to write balanced chemical equations. So in order to write balanced chemical equations, you write the formula of each one and then you balance the equation. And sometimes he asks you to write the state of each compound. Now, states are denoted by symbols. So if it's a solid or it forms a precipitate, then you put S. If it's a liquid, you put L. If it's a gas, you put G. If it is something that is dissolved in water or something that is soluble in water, you put AQ. That means aqueous, dissolved in water. Now, in order to write chemical formula, you have to realize that some molecules are diatomic. Diatomic means if they're standing on their own, they need a 2 under it. So if I say something plus hydrogen, I can't just write it H. It has to be H2. If I say something plus nitrogen, or nitrogen plus something, nitrogen is N2, oxygen is O2, and then all the halogens, fluorine, chlorine, bromine, iodine, are all diatomic. So if you look at your periodic table, it's hydrogen, and then NOF, and everything under the F, these are diatomic. Diatomic means when you write them in the formula, they have to be with a 2 below them, because the molecule, diatomic means the molecule is made up of 2 atoms. So let's try balancing these equations. When you balance any equation, you look on both sides of the arrow. Can you see where the arrow is? Where is the arrow? Anything before the arrow are called reactants, and anything after the arrow is called product. Now, the number of atoms in the reactants, the total number of atoms in the reactants on the left side of the arrow, have to be equal to the total number of the atoms on the left side of the arrow for each element. So zinc, for example, Zn, how many zinc atoms do we have before the arrow? I have only 1 on the left side of the equation. What about after the arrow? I still have only 1. So in this case, zinc is balanced. Let's count hydrogens. How many hydrogens do I now have before the arrow? I have only 1. How many hydrogens do I have after the arrow? After the arrow, I have an H2. That means I have 2 atoms. Now, on one side, I have 2 atoms. On the other side, I have only 1. I have to increase the one that is less. So which one has less number of atoms? The side before the arrow. So I need to increase the hydrogens on the side before the arrow. Now, in order to increase anything, I put a number before it, which we call a coefficient. So if I put 2 before the HCl, that now means that I have this 2 before the HCl, means I have 2 of the HCl. That means I have 2 hydrogens and 2 chlorines. So when you put a 2 in front of it like this, it means that you have 2 hydrogens and 2 chlorines. Please remember that when you're balancing the equation, you don't change the numbers that are down. You change the numbers that are before the compound, which we call the coefficients. So here I put 2 before the HCl. And now this means that I have, before the arrow, I have 2 hydrogens. After the arrow, I have 2 hydrogens. Before the hydrogens, how many chlorines? Now that I put the 2, that means I now have 2 chlorines before the arrow. I also have 2 chlorines after the arrow. So in this case, the equation is now balanced. Do we understand how we balance this? Okay, let's try this. Complete the following equation for the reaction. So basically, he wrote the reaction and he's asking you to balance it. So let's count on both sides of the arrow. Before the arrow, how many Mg? Only 1. After the arrow, how many Mg? 1. Remember that MgCl2, the 2 below there applies only to what is before it. The 2 that is down applies to only what is before it. So in MgCl2, I have 1 magnesium and 2 chlorines. So 1 magnesium on this side, 1 magnesium on this side. How many hydrogens before the arrow? I have 1 hydrogen before the arrow. How many hydrogens after the arrow? We said if I have H2, that means I have 2 atoms of hydrogen. That means I need to put 2 in front of the HCl in order to have 2 hydrogens. And we said if I put a number before it, it applies to everything after it. So the 2 before the HCl means I have 2H and 2Cl. Now I have 2Cl before the arrow, and I also have 2Cl after the arrow, so this equation is now balanced. Do we understand how to do this? Okay, let's try this one. I have SiO2 plus C to give Si plus CO. So let's count on both sides of the arrow. How many Si before the arrow? 1, because that 2 under the O applies only to the O. So I have 1 Si before the arrow, 1 Si after the arrow. How many oxygens do I have before the arrow? I have SiO2. That means I have 2 oxygens. So I have 2 oxygens before the arrow. I have only 1 oxygen after the arrow, the one that is with the C. So that means that I need to put a number, and we said we put a number where? We put a number before the CO. Not at the bottom, not somewhere in the middle. It is before the CO. That means that I have 2 molecules of CO. And that means I have 2C and 2O. So now I have increased the number of C's after the arrow. That means I need to increase the number of C's before the arrow, and now this is balanced. Can you see that this is now balanced? Okay, try the next one. Fe plus HCl to give FeCl2. First of all, plus what? I will tell you that it is plus hydrogen. For now, that a metal with acid gives hydrogen gas. Okay, let's keep that in mind, and we will talk about it again when we do acids and bases. Now let's balance this equation. Now, before the arrow, I have 1 Fe. After the arrow, I have 1 Fe. Before the arrow, I have 1 H. After the arrow, I have how many H's? 2. That means I need to put a 2 in front of the HCl so that I have 2 and 2. Remember, we increase the one that is less. But when I put a 2 before the HCl, that means I now have 2 H's and 2 Cl's. So now I have 2 Cl before the arrow. I also have 2 Cl after the arrow, and that means that equation is now balanced. Okay, these are easy. Let's try this one. Now, when sodium hydroxide is added to ammonium phosphate, ammonia is released. Complete the symbol equation for this reaction. First of all, there is a product missing. So let's figure out what this product could be. This is ammonium phosphate plus sodium hydroxide. And he says it will give sodium phosphate plus ammonia plus what do you think is missing here? What haven't we used? We haven't used the OH that is in the sodium, and we haven't used one of the H's in the NH4, right? And OH make up what? They make up water. Okay, now let's try balancing it. If you have on how many nitrogens do we have before the arrow? Can you tell me how many nitrogens we have before the arrow? We have NH4 bracket 3. Now when I have NH4 bracket 3, the 4 applies only to the hydrogen. But the 3 that is outside the bracket applies to everything inside, and it is multiplied by everything inside. And that means that I have 3 nitrogens and 12 hydrogens in that compound. Do you understand how? So I have 3 nitrogens on that side, 3 nitrogen on the other side by increasing the 3, by putting a 3. Now, what else do we have? How many hydrogens, how many sodiums do we have? On before the arrow, we have 3 sodiums. Can you see that we have 3 sodiums before the arrow? After the arrow, we have 3 sodiums. So that is balanced. And how many hydrogens do we have in total before the arrow? Before the arrow, I have 3 times 4. That's 12 plus 3. So I have 15 hydrogens on that side. How many hydrogens on the other side? I have 3 times 3. The 3 in front of the ammonia. 3 times 3 is 9. Plus 2 times 3, 6. 6 and 9 is 15. How many oxygens do we have before the arrow? We have 4 and 3. Can you see that we have 4 and 3 before the arrow? So that's 7. On the other side, I have 4 and 3 because the 3 in front of the water applies to everything in the water. Can you see that it's now balanced? Okay. Complete the chemical equation for the reaction of aqueous bromine with, so he's saying I'm reacting bromine with potassium iodide. So if I'm reacting bromine, I need to write Br2. Remember that we said bromine is diatomic, so I cannot just write it Br and that's it. It is Br2. And so that means that I have 2 Br before the arrow. So what should I do after the arrow? I should put it 2 in order to have 2 Brs, and also 2 Ks before the arrow and 2 Ks after the arrow. 2 iodines, 2 iodines. So now this is balanced. Are you getting familiar with all of this? Okay. This says lead nitrate solution. And remember that we said if something is solution, that means it's aqueous. And potassium chromate solution react to form a yellow precipitate. The word precipitate means a solid that forms from the reaction. So a yellow precipitate is the solid that forms from the reaction. So we said, he says, write the state symbols. Lead nitrate, he tells me it's a solution. And that means that it is aqueous except for the lead chromate, which is solid. We said the lead chromate is a precipitate. That's a solid that forms in the reaction. So lead chromate is a solid, and everything else is a solution, so that is aqueous. Do we understand how to write state symbols? Use information from the equation to determine the charge on the chromate ion. Now, where is the chromate? He wrote K2CrO4. So what do you think is the valency of CrO4? The valency of the CrO4 is the 2 that is under the K, right? And it is an anion. It comes after the potassium chromate. The potassium has to be positive. Remember that the first one has to be positive. If you're not sure which one is a cation and anion, in K2CrO4, the first one has to be positive, the next one has to be negative. So the CrO4 has 2 negatives because its valency is 2. Do you understand how I got that? Because he wrote K2CrO4. The 2 under the K is the valency of the CrO4, because we said we put the valency of one under the other. So if the K has a 2 below it, that's the valency of the chromate. Now, is it 2 positives or 2 negatives? We said this is the one that comes second. Anything that comes second in the molecule is an anion. The metal is the one that has to be positive. So K has to be positive, so the CrO4 has to be negative. So that means that the charge on the chromate ion is 2 minus. A mixture of titanium 4 oxide and carbon reacts with chlorine to form titanium 4 chloride and carbon dioxide. How are you going to write that? Titanium 4 oxide. How did we write titanium 4 oxide? Titanium 4 means that the valency of titanium is 4. So I'm supposed to write 4 under the O, not 2. But then the valency of oxygen is 2. So actually it should be Ti2O4. But if this is 2 and this is 4, I can simplify them 1 to 2. So that is why we wrote TiO2. And carbon, so that's a C. And if something is alone, you ask yourself, is it diatomic or not? Is carbon diatomic? No, so I don't write anything below it. Reacts with chlorine. Chlorine, we said, is a halogen, and we said all halogens are diatomic. That means I cannot just write Cl, it has to be Cl2. To form titanium 4 chloride. Valency of titanium is 4, so I put it under the chlorine. Valency of chlorine is 1, so I don't write anything under the titanium. Plus carbon dioxide, we said carbon dioxide means carbon with 2 oxygens next to it, so it's CO2. We haven't finished yet. Have we finished? We haven't. Because when you write a chemical equation, it has to be balanced, even if he doesn't tell you to be balanced. Because a chemical equation cannot be written without balancing. You cannot have a chemical equation that's not balanced. So the fact that he just says write a chemical equation and didn't tell you to balance it, that doesn't mean that you're not going to balance it. Actually, you have to balance it. any chemical equation that is written has to be balanced. So I need to put 2 in front of the Cl2, because I had 4 Cl on the other side, so I need 4 Cl before the arrow. Everything else is balanced. Can you see that everything else is balanced? 1 titanium, 1 titanium. 2 oxygens, 2 oxygens. 1 carbon, 1 carbon. The only thing that wasn't balanced was the chlorine. So 2 times 2 is 4. Remember that when you put a 2 in front of it, it's multiplied by the number that is below it. Do we understand this? Okay, let's try this. Oxygen is removed from air by passing it over heated copper. Complete the equation. So oxygen is removed from the air. That means that the copper is reacting with what? With oxygen. Now we need to balance. Again, you have to balance. So he put 2 Cu for you, so you have to put 2 Cu, and you needed the 2 Cu in order to balance the oxygens. You have O2 before and 2 oxygens after, so now it's balanced. Okay. Potassium reacts with bromine at room temperature to form potassium bromide. So potassium is K plus bromine, Br2. Bromine is diatomic, it has to be Br2, to give potassium bromide, KBr. And then you balance. You have 2 Brs before the arrow, so you needed to put 2 in front of the KBr, but that means that you've ruined the K, so you need to put 2 in front of the K. Were you able to balance it? And then he says include state symbols. So K is a metal. All metals are solid, so you put an S. Bromine, you should know that bromine is the only liquid non-metal in the periodic table. The only liquid non-metal in the periodic table is bromine. KBr is a solid. It's just like sodium chloride, potassium bromide, lithium iodide, anything. All of these are solids. Complete the chemical equation for this reaction. So he wants you to balance. So let's try balancing. Before the arrow, how many sulfurs do you have before the arrow? Total number of S atoms before the arrow. You have S alone, so that's 1, but then you have another S in the H2SO4. So you have a total of 2 S's, and that means you need to put 2 in front of the sulfur. But then, once you've done that, you've ruined the oxygens. So you need to put 2 in front of the sulfuric acid. Can you see what we did? So now let's take a look at what we've done after this. When I put 2, I needed to put 2 in front of the sulfuric acid in order to balance the hydrogens. So you had 4 hydrogens after the arrow, so you need 4 hydrogens before the arrow. That ruined the sulfur because now I have 2 and 1 before that, so I have a total of 3 sulfurs, so that is why I have to put 3 in front of the SO2. Now let's count the oxygens. How many oxygens before the arrow? I have 2 times 4, and that's 8. Now after the arrow, how many do I have? I have 2 from the water, and I have 2 times 3, which is 6. 2 times 3, which is 6. So I have 6 and 2, 8, and the other side is 8, so this is now balanced. Okay? Okay. Sulfur dioxide is produced on a large scale by heating iron pyrite with this formula, strongly in air. The iron pyrite reacts with oxygen in the air, producing iron 3 oxide and sulfur dioxide. Write a chemical equation for the reaction between what and what? Between what? Iron pyrite and oxygen. He gives you the formula of iron pyrite, FeS2, and you want it with oxygen, and he tells you it gives you Fe2O3 plus sulfur dioxide. How do you write sulfur dioxide? SO2. How do you balance this? You have how many iron before the arrow? I have 1 Fe before the arrow, 2 Fe's after the arrow, so I need to put 2. But then as I go along, I find that actually after I put 2, I need to put some more in order to make them balanced. So you keep going back and forth, and you'll find that it is balanced if you put these numbers. Okay? Which of these is the formula of a molecule of bromine? Remember that we said bromine is diatomic. Diatomic means the molecule is made up of 2 atoms, and this is how you write it. Br2, so your answer is D. Write a chemical equation for the reaction between magnesium and nitrogen to form this compound, magnesium nitrite. So basically you're writing magnesium. Magnesium is a metal, it's not diatomic, so you don't write any 2 under it. but nitrogen is diatomic. I cannot write just N. It has to be N2 to give this compound that he's talking about, and then I need to balance. How many magnesium before the arrow? 1. How many magnesium after the arrow? 3. And that means I need to put 3 in front of the one that is less. Now, is that balanced? 3 magnesium, 3 magnesium, 2 nitrogens, 2 nitrogens. That's balanced. Okay, balance the equation between sodium hydroxide and sulfuric acid. So again, we're going to count on both sides of the arrow and increase the one that is less. So how many sodium before the arrow? 1. How many sodium after the arrow? 2. So I need to put 2 in front of the sodium hydroxide. That means that now I have 2 sodium, 2 oxygen, 2 hydrogens, that compound. Okay, now hydrogens. How many hydrogens do I now have before the arrow? Remember, as a hint, always keep the oxygen till the end. Always keep the oxygen till the end. So let's count the hydrogens. Before the arrow, I have a total of 2 and 2, so I have a total of 4 hydrogens. After the arrow, I have only 2 hydrogens in the water, so I need to put 2 in front of the water. Now, how many oxygens do I have now? Can I count them? Oxygens before the arrow, I have 2 and 4, so that's 6. After the arrow, I have 4 and 2, and that's 6, so now this is balanced. Okay, let's try writing balanced equations for the following. Nitric acid plus calcium hydroxide to give calcium nitrate plus water. So first of all, how do we write nitric acid? We said nitric acid, acid is SH with NO3. H is valency 1, NO3 valency 1. Calcium hydroxide, we said calcium, Ca, hydroxide is OH. Calcium is in group 2, so its valency is 2, so I have to put 2 under the hydroxide. To give calcium nitrate, again calcium is valency 2, nitrate is 1, so I have to put 2 under the nitrate. Plus water, that's H2O. And then I balance. Remember that you have to balance. So you will find that you need to put 2 in front of the HNO3 in order to balance it, and 2 in front of the water in order to have equal number of atoms. How do you write barium chloride, sulfuric acid to give barium sulfate plus hydrochloric acid? Were you able to write that? So this is how you write it. Okay? Do we understand this? Let's try this. Silver 1 nitrate means the silver has valency of 1. Calcium chloride to give silver chloride plus calcium nitrate, and this is how you should be able to write it. Can you try this one? The next one, iron plus copper 2 sulfate to give copper plus iron 2 sulfate. Can you write that? Okay, you should be able to write this. And it's all balanced like that. Okay, so that's it for our chemical formula and equations. Please sit down and practice all of this. It's very important.